Okay, let's do some homework. So first off, we have 10. When we look at this, its form is stuff times stuff, so I'm going to do the product rule. So I take the first times the derivative of the second, plus the second times the derivative of the first. Notice I've marked it with a derivative, and I haven't even taken a derivative yet. Well, then the derivative of this is just this, and the derivative of that is just that. So then when you distribute through, you end up getting these terms. And when you distribute through, you end up getting, well, let me make sure that's clear. When you distribute through this, you end up getting these two terms. Okay? So then when you take together your common terms, it simplifies to this. But then we don't like negative exponents, so we rewrite it like this. Okay, you can stop taking the derivative at this point if all I say is to take the derivative, but then if it says take derivative and simplify, you must go to here. Looking at 14, the form is the quotient rule, so its form is stuff divided by stuff, so I use the quotient rule. So it's going to be low d high minus high d low over low squared. The derivative of this is just that. And the derivative of this is simply 1. So then distributing this out to both those terms, I get this. So at this point, you're done taking the derivative. But if it says also simplify to continue to move on, if you distribute this, you get this. Well then, if you have x to the 1/2 and negative x to the 1/2 and a half x to the 1/2, that would be a negative half x to the 1/2. So then this to the negative 1/2 is the same as 1 over this. So you have something that looks like this, but then I don't like those exponents. So I multiply the top and bottom by this well-chosen 1. And when you distribute through, the top becomes 2 minus x, and the bottom just becomes this. So that's what I'd have. Again, if all I say is take the derivative, you can stop there. For number 24, it should be clear that the form of this one is stuff divided by stuff. So in that case, we do low d high, make sure that high is green, low d high, minus high d low over low squared. Well, then the derivative of a, here it should be clear that a, b, and c are constant, right? And then since we have f is a function of t, t is a variable. So the derivative of that function of t is going to give us this. But then you want to be really careful, and we're taking all of this minus all of this. So I put all of this over here in big brackets. And when you do, you can then distribute this to get all this, right? And then distribute a to get this. Well, then why is that great? Because, let's see, abt squared minus 2abt squared is negative 1abt squared. And then act cubed minus 3act cubed is minus 2act cubed. So it simplifies to this, but then notice if we factor out, if I take this bottom and I rewrite it inside, if I factor out, let's see, would that be a t squared? So the most I can factor out on top is a t squared. So then on bottom, I wish I had a t squared. So all you have to do is inside here, if you factor out one of those t's, well then things multiply together, raised to a power, you just distribute, and you get t squared times stuff squared. Putting that in the bottom, then now those t squareds cancel, and you're left with this. So again, if you were just taking the derivative without simplifying, you could stop here. If you must simplify, you get to here. 36, it says find the derivative of this thing at a point. Well, since they want the equation of the tangent line at a point, then this is my point, and this is the equation of a tangent line. So I know I can put in my x1 and my y1, and then all I have to do is find m. But m is just the derivative, plug in x1. So if I plug in 3, I need to take the derivative and then plug in 3. So I come over here. I say that the derivative is just the derivative of this, but the form of this thing is stuff divided by stuff, a function divided by a function. So I do low d high minus high d low over low squared. The derivative of this is 1, and the derivative of that is 2x. So then on top what I have is negative 2x squared, and 1x squared is negative 2x squared. So that's my derivative. So if I then take my derivative and plug in 3, I then just plug in 3 for x. You're going to end up getting negative 0.17. So that means since the derivative at my point is negative 0.17, that is the slope of the tangent line at that point. So that is my tangent line. 40B and D. So first for B, if I take the derivative of a product, it's just first derivative second plus second derivative first. And then if they want it at 4, I just plug in 4. And then it turns out that they told me that f of 4 was 2, so I can plug it in here. They told me that g prime of 4 was negative 3, so I can plug it in here. They tell me that g of 4 is 5, so I can plug it in here. And they tell me that f prime of 4 is 6, so I can plug it in here, and I'm done. So we were given these things over here. For D, again, if we're given those same things and you ask me to find this derivative at 4, well, I'm just going to take my general derivative and do low d high. So in this case, what was I making low? Low is yellow. So I'm going to do low. So it's going to be low d high minus high d low over low squared. So it's low d high minus high d low over low squared is going to be my derivative. But the derivative of g is just g prime. And the derivative of a sum is just the sum of these two derivatives. So that is h prime. So if they want h prime at 4, it just means you plug in 4 everywhere where there's an x. By doing that, I get my derivative in terms of f and g, and the derivative of f and the derivative of g, which they gave me all that information. Plug in and you're done. 38, it says that my revenue is price times the quantity that I sell. But guess what? Quantity is also a function of price. Because, for example, you probably sell less if you make it really, really expensive. So revenue is just price times some function of price. So if I take its derivative, well, the derivative of this product is going to be the first times the derivative of the second, plus the second times the derivative of the first. But the derivative of p with respect to p is just 1. So that is the change in revenue. So then they ask, what does f of 10,000 mean? Well, f of 20 equals 10,000, excuse me. So what does f of 20 equals 10,000 mean? Well, f of 20 they defined as the quantity. So this is saying that at a price of $20 per yard, you sell 10,000 yards. Well, then f prime of 20 would be the same as q prime. And so remember, q prime is just the change in quantity over the change in price, right? So in this case, it would be change in quantity over the change in price, right? We can think of it like that. So quantity is in yards and price is in dollars. So really what we have is that at a price of $20, an increase of $1 in price will cause us the quantity to go down by 350 yards. And then they say find R prime of 20. Well, we said that this was the change in revenue. And so the change in revenue at $20 would just be plugging in 20 for the price and seeing how the revenue changes. Well, this is 20. This they gave us was 350. And this they gave us, f of 20 was 10,000. So when you work it all out, you end up getting $3,000 per $3,000 of revenue for every $1 of price increase, right? So what this is really saying is that at a price of $20, if you were to have a change in price of $1, you would get a change in revenue of $3,000. So that's my change in revenue with respect to price. If this goes up by $1 when you're at 20, then your profit's going to go up that much. Your revenue, excuse me. Cool. All right. And this last one says your biomass is equal to, this is the biomass is equal to N, which is the number of individuals, also known as the population, times the average mass. So it says that the product of N, it says in the case of guppies, breeding occurs continually. So suppose at time t is equal to 4, the population, so the population N of 4, population is equal to 820 guppies. Guppies is 820. And then they say it's growing at a rate. So that would mean M prime of 4 is equal to 50 guppies per week. And then it says, well, the average mass, so in other words, the mass at 1.2, the average mass at 4 weeks is equal to 1.2 grams. And that the mass is increasing at a rate of 0.14 grams every week. So now it says, at what rate is the biomass increasing at time equal to 4? So this, we know that in general, the biomass is going to be, its derivative is the product of N of t, M of t. So it's going to be first derivative of second plus second derivative of first. So that means if you want to know what happens at 4 weeks, that's going to be N at 4 times M prime at 4 plus M at 4 times N prime at 4. So N of 4, they said, was 820 guppies. M prime, they said, was 0.14 guppies per week. Plus M at 4, they said, was 1.2. And then this is going to be N prime. So the mass N prime is 50 guppies per week. So how does the change in biomass come out? Well, as you change the mass, this is going to account for the change in mass. So we have this many, but the mass changed like this, and this is going to account for the change in number. We changed in number this much, but this is the average mass. So when you do this, you're going to get, hey Siri, what is 820 times 0.14? 114.8. And then 12 times 5 is 60, right? So yeah, it's going to be 60. 1.2 times 50 is going to be 60. So, Richard reminder. Okay. So then when we do this, this is going to be 174.8, and its biomass is changing in grams per week.